MongoDB or Redis. This is not simply a question of which one is faster. In many systems, these technologies are not direct competitors. They solve different problems and often work together. In this video, we will compare their data models, memory and disk usage, persistence, query capabilities, scaling, consistency, and real-world use cases. Let's begin with MongoDB. MongoDB is a document database that stores data in flexible, JSON-like BSON documents. Documents live inside collections. Complex objects such as users, orders, product catalogs, or content can include nested fields and arrays in one document. The schema is flexible, but that does not mean you should design without a schema. A reliable system still plans fields, data types, relationships, and validation rules. MongoDB provides a powerful query engine and can serve as the durable primary database for an application. Redis is primarily an in-memory data store. It provides data types such as strings, hashes, lists, sets, sorted sets, streams, and JSON. It offers extremely fast access by key and atomic operations for its data structures. These properties make Redis an excellent fit for caching, sessions, rate limiting, counters, leaderboards, distributed locks, real-time messaging, and short-lived state. Calling Redis only a key value store is also incomplete. Modern Redis can support broader workloads, including streams, search, vectors, and document-oriented scenarios. The most fundamental difference is the data model. In MongoDB, a product document can contain price, category, tags, inventory history, and nested variants. You can create indexes on fields and execute expressive queries. With Redis, data is commonly accessed through a key you designed in advance, such as product:42, session:ABC, or rate:user:15. Redis can build indexing behavior with data structures and additional capabilities, but this is not identical to MongoDB's general-purpose query and aggregation model. Complex filtering and reporting are natural MongoDB tasks. Fast access by a known key is Redis territory. For persistence, MongoDB is designed as a disk-backed operational database. The Wired Tiger storage engine uses memory as a cache while keeping durable data on storage. Redis primarily works in memory, but it offers disk persistence options. RDB creates point-in-time snapshots at configured intervals. AOF records write operations in an append-only file. You can use both, choose one, or disable persistence. The decision changes your potential data loss window, restart time, disk input-output load, and cost. Using Redis does not remove the need for backups or restoration testing. A single performance number would be misleading. Redis usually has an advantage for extremely low latency operations because it keeps data in memory and uses key-oriented commands, but the dataset and overhead must fit within available memory. MongoDB is disk-backed, but it keeps active data in cache and can deliver strong performance with appropriate indexes. It is more natural for complex queries, aggregations, large document collections, and durable storage. Missing indexes, uncontrolled collection scans, or a poor document model can slow MongoDB. Huge keys, large values, and expensive commands can also create latency in Redis. Consistency and transaction models are different as well. MongoDB provides atomic single document writes and supports ACID transactions across multiple operations, collections, databases, documents, and shards when needed. Good document design should still reduce unnecessary transaction use. Individual Redis commands are atomic. Multi and exec can queue command execution, while Lua scripts or server-side functions can combine operations atomically. But Redis transactions do not behave exactly like relational or MongoDB multi-document transactions. Do not design the system expecting traditional rollback behavior when a command fails. For high availability and scaling, MongoDB replica sets provide redundant copies and automatic primary election. For larger datasets, sharding distributes data across machines using a shard key. A poor shard key can concentrate traffic on one shard or create inefficient scatter-gather queries. Redis Sentinel monitors primary and replica deployments, and provides automatic failover without data sharding. Redis cluster partitions the key space across nodes using hash slots for horizontal scaling. Redis replication is asynchronous, so under certain failover conditions, the latest acknowledged writes may be lost. Your architecture must account for that possibility. Consider a real e-commerce architecture. Products, customers, orders, and payment states can be stored durably in MongoDB. Frequently viewed products are cached in Redis. User sessions are stored in Redis with expiration. API request counters are incremented in Redis for rate limiting. Background work or real-time notifications can use streams. When a cache entry expires, the application reads the current value from MongoDB again. In this model, MongoDB is the source of truth. Redis is the acceleration and temporary state layer. If the cache disappears, the system can rebuild it from MongoDB. So which one should you choose? MongoDB is the natural option when you need flexible documents, durable primary data, expressive filtering, aggregation, transactions, and large datasets. Redis stands out when you need extremely fast key access, caching, sessions, rate limiting, counters, leaderboards, distributed locks, or temporary data. It can be dangerous to store a critical financial record only in a Redis instance designed as a disposable cache. It is also inefficient to execute the same expensive MongoDB query on every request when a safe cache would work. Decide based on access patterns, durability requirements, consistency, and acceptable data loss. In summary, MongoDB is powerful for durable, queryable document data. Redis is powerful for extremely fast access and operational state. In many modern architectures, the correct answer is not MongoDB or Redis, but MongoDB and Redis. Your API can store primary data in MongoDB while using Redis for caching, sessions, and rate limiting. Subscribe to the channel for more backend architecture comparisons and real-world engineering content. Are you using MongoDB, Redis, or both? Share your experience in the comments.